Hello, we're going to use what we have learned so far and create an effect like this using a fully custom OpenCL DOP solver. So let's jump into Houdini. So here we have the setup from the previous volume lesson, and that was a few lessons ago. And we created a geometry network that we called setup. And inside here an empty volume and a volume VOP with a small program to create this density volume. So let's go from here and set up a fully custom simulation. So first of all, I want to move this up so it is above the ground plane. So press tab and type transform. And let's connect this last and select and press P and move this up 1 meter in the y-axis. And then let's show this by pressing space and H. Okay, so next let's add a null node. So tab and null. And I am going to connect this and call it source. So this is our source for this simulation. And to keep clean, I am also going to create a box around this. So if you show this menu and select these nodes and create network box, then we can create a box around these nodes. And you can type here source. And normally when you create a simulation, you want to keep very organized. So the next step is to create the simulation. So for this, I'm going to create a DOP network. So press tab and type DOP and select DOP network. And I will connect the source into the first input and call this the, let's see, smoke sim, or we will see what we will do. Okay, so let's say we are making a custom smoke sim here. And next I'm going to add custom parameters on this node. So if you select this and right click, and then go to parameters and channels and edit parameter interface, then you can add your own parameters. I'm also going to press P to show the existing interface. So we are going to add one more tab before these tabs. So let's go to the left here and drag a folder before the object merge. So this will be the first tab in our interface. And I'm going to call this, let's say, smoke, and label smoke. And then press apply. And now you can see a new tab in this interface called smoke. And here we'll add our simulation parameters. So first of all, when we created our volume, you saw that we had size, center, and div size. And these are very important parameters for a simulation. So first of all, we want the div size. You can see this is usually called div size in small letters. So let's add a float by dragging a float parameters from here into our smoke object. And I will call this div size. Div size. And call this div size or division size. And that is a float. And next I will set the default value to be 0.01 by going to the channel tab and type the value here. And go back to the parameter tab, and here we can set the range so that we can have a minimum and a maximum value. So I will say 0.001 as the minimum value and 0.1 as the maximum value. And now press apply. And here we can see that we now have, if you select again the smoke sim, a division size similar to what we have here in the volume div size. And this can be changed between 0.01 and 0.1. So let's go back to the default by going to revert to defaults. So you can also use Control middle mouse button. And next we also want to have the size and center. So this we will call size XYZ. So let's go back to our editor here and let's add an integer vector of 3, of size 3. So I'm dragging this also into the smoke. And here I will call this size. Or actually I will use not an integer vector. I will change this to be a float vector. So float vector 3. And call this size. And size. And let's also set the default as before, and I'm going to use 1 by 1 by 1, so 1 square meter in size. And for range, I'm not going to change that this time. So let's press apply, and then we can see now in the smoke sim we also have a size field that is called size X, size Y, and size Z. And next I want to add the position or center, and this is usually called TX, TY, TZ. So let's select again the smoke sim and drag in another float vector 3 into the smoke tab and call this center. And I will call this T, and then I will label this center and go to the default values, and we can keep this as 0 and press apply. So now we have all the parameters we will need. Not all, but the most basic parameters we will need for our smoke simulation. And then we can say accept. And we also want to add a box around here. So let's press this icon again. And then we can call this simulation. Okay, so now let's dive into the simulation and set that up. So I will double click on the smoke sim and then delete this output node and go to the geometry spreadsheet so we can see what we are creating. Before that, let's go up and go back to the smoke sim, press P to edit, and then go to simulation and disable the cache. Go to cache and disable cache simulation, and that makes sure that we can see the most recent results instead of the cached result. And let's go back into our simulation setup. Okay, so now we can see here our simulation data. So I will start by creating an empty object. So press tab and type empty, and then select empty object. And I will call this smoke. And then press P and change the object name to $OS. And that will create, as you can see on the left, a smoke object. And next we are going to need some fields to work with. And the field is basically a volume. But when we create simulations, we call these fields. So first of all, we want a density field. So let's press tab and type SOP, and let's see what we have. So we want a SOP field, a SOP scalar field. So that will be SOP scalar field, okay. And connect this to the smoke object to the left input. And we will call this the density. And if we open the timeline and press rewind, we still don't see it. So let's select this density field and again rewind. And now we can see we have something called a scalar field inside our smoke object. But we want to call this density. So let's press P, and here we are going to change the data name to $OS for operator string. And now we can see it is called density. And you can also find here the size. So we are going to take our division size and center and fill these from the parameters we just created. So go to the division type and type CH and an opening bracket and a citation marks with a ... and this means go up one level. And then a slash, and then div. And you can see we have our div size. And then a quote and an end bracket, or end parenthesis. And if you click on this, you can see it is bringing in the value we had, 0.01. And speaking of that, we also want to use that same value. So let's go up and go to our density at the top here and press P. And we want to do the same thing here. So I'm going to go to div size, type CH, open parenthesis, and a quotation mark, ... slash, and smoke sim slash div size. So this will bring the div size from the smoke simulation. And if we now click this, we can see we have that same value. And I'm also going to, well, not necessarily, I will keep this there as is. So let's go back into the simulation. So now we have a density field, and this will be brought in from this first input. So let's go back here and press P, and let's bring in that field. First we have to fill in the size and center as well. So let's type CH and a quotation mark ... slash size X and end that, and you can check that we got the right value 1. And then let's copy this over to the next and change this to y, and go to the next and paste this as well and change this to a z. So now we have all the sizes brought in from our parameter. And we will do the same with the center. So let's type ch and a parenthesis and a quotation mark dot slash, and this is called tx. And then let's copy this expression and paste it into the next and call this y, and paste it to the next and call this z. And now if you click, you can see we have our size in here. Okay, so now we want to bring in the density from the first input. So I am going to this subpath field and type a backtick and then op in input pass, and it's see op input pass and dot as usual, and a comma and a 0 for the first input, and then a backtick at the end. And middle click this and see if you get the right. So obj setup source. So now this source is automatically assigned to this density field. And let's look here on the left and rewind. And if you click on density, you can see our parameters here. And this is still okay. We have a resolution of 100 by 100 by 100. So this looks good. And now we want to visualize this. So let's add a visualizer. So press tab and type visual. Let's see. Should be a scalar field visualization, and select that, and then connect this into this other input on the density. And if you look at what happens here, you can see that inside the density we have a visualization. And that is because what we connect here will appear inside the density here. And we want to call this something that is easy to understand. So I'm going to call this density and viz for visualizer. And then let's go to the scene view and see what we have. So let's rewind, go to the density visualizer and select this and press P, and then show guide geometry. And I want, for one thing, a bounding box. So here we can see the size that we created. And I also want to use smoke to show the smoke volume. And you can already see that something is not correct. You can only see the bottom part of the volume. So let's press P and go up and select the smoke sim and press P and go to the size. So here we want the size to be 2 by 2 by 1 and centered at 1. And now if you go inside again, you can see that we have a size for the simulation that encompasses the full volume, also with a little bit of margin, so we can have things move around in the simulation. Okay, so far this does absolutely, well, it does something, it brings in the volume. So let's continue with the basic setup before we create the actual simulation. So let's go up, and we want to cache this simulation. So before we do that, we also want to define the frame range. So let's change here in the timeline to 24 frames. And then I am going to create a file cache. So press tab and type file cache and connect this after the simulation. And we can call this smoke cache. And this means that we can write out our simulated results, so we don't have to resimulate it each time we want to render it. So let's change here the path. So I'm going to call this data, and that assumes I set up a data variable up here under edit aliases and variables to point to my disk. And I will call this EXR and heap name and slash and operator string $F4. And let's see what this will expand to. So this is now, I have not defined the data variable yet, so I will do this later. So let's just keep this as is. And once we have simulated and written out the results, we can do a load from disk. Let me just replace the data with slash volumes data, which is where I keep my data files. So now we can simulate this, or rather we can write this out. So if I go here and type save to disk, then it will save all these frames to the disk with the names here. And then I can load from disk. Actually, I did forget one step before that we need after the smoke sim, because this data that comes out here is not actually the density field. So we need to actually grab the density field from the simulation. So let's add another node in between that is a DOP import. So DOP import, and then connect this between these two nodes and select it, press P, and here we select the DOP network to be the first input. So again, backtick op input path and a parenthesis and a dot comma 0 and a backtick. And if you middle click, you can see this. So op input path. Let's try again. So there is something wrong in this expression, so it should go up input path. Okay. But this should work. Let's try go up 2 steps. This. Okay, so this should just be a dot, because you don't see it as going up outside the node. It's already in the right level. So use only one dot here. And then for the object mask, we can select smoke as our object. And that, you remember, we created in here the smoke object. And let's go up. And next we are going to import fetch geometry from DOP network. And here use DOP object name that is smoke. So let's see here. Okay, this is the field. So we want to grab the density field. So if you look here in the geometry spreadsheet, then this density is the object name. So let's go up again. And here type density. And you can see already that we have data coming in here. And we don't need all this stuff, so you can disable these check marks. And do not trigger simulation and no point velocities. So now if you look at this node and go to the scene view, you can see we have this density that is going through the simulation. It doesn't do anything with it, but it is simulated. And let's go back to our smoke cache, and if we now save to disk, then you can see that it is loading this data from disk and it doesn't need to simulate. And then we can add a null here and call this source, and let's call this out. And this is what we would render. So let's also set up the render part. So this lesson is getting a bit long, but let's keep going while we have the momentum up. So let's go up to this level. And to render this, we first of all need a camera. So you can frame your view and then go to this and select new camera. And then open this bar and press the lock key. So here we can change the camera angle viewed from the camera. And when you're happy, press the lock again. So the camera is locked to this position. And next we want a render network. So press tab and type ROP and create a ROP network. And before that we may also want a light. So let's press tab and type light. And select the light and change this to be a sunlight, for example. And then you can set the angle on this, on the rotate parameters. So if you middle click, then you can go up and down and left and right to change these values. So let's see. Well, you can tweak this as you like later. So I'm just going to use -30, -60 for now. Okay, so now we have a camera and a light. And next we are going to create an OpenGL render node. So double click the ROPNet and press tab. And before we render, we need to make sure that we have the simulation cached. So type fetch here and call this fetch sim. And press P, and in the source you can select in this setup smoke cache render and accept. So this will trigger the simulation cache and store the simulation to disk. And next we can do our render, and we need to simulate the complete simulation first before we start to render. So let's add a batch node. So press tab and type batch. And press P to select and always render inputs full frame range. So that will make sure that we have the full simulation done before we start to render frames. And then finally press tab and type OpenGL and connect this last. And select it and press P. And here we can see we have the camera already set and the candidate objects. So normally you don't want any candidate objects and lights. You want to select force objects and force lights. So let's go to force object and select the setup. So this is what we will render. And then we want our light. So let's go here and force our H-light 1. And then go to output, and the output image will be, again, in my case, volumes data EXR and $hip name /$OS dot $f4.exr, and we can see this will expand to this file pattern. And then let's see, we don't need any color corrections, we can disable that. And because we are using EXRs, we can select the EXR compression. So let's go here and select Dreamworks Animation A, as I explained in another video. So now we are ready for rendering. And one more thing is to set the frame range, so render frame range, so 1 to 24. And then let's go up to the camera, press P, and here under render view, here you can select the resolution, so 1920 by 1080. So now we have all we need. So we have our setup that includes the simulation, we have the camera, the light, and the render. And we have our simulation parameters set up. And next we just need to go into the DOP network and start to create our custom simulation. But I think this is a good point to stop for today, and let's continue in the next lesson. So this is what we will eventually achieve when we have finished this small project. I hope this was helpful, and see you next time. Over and out.